Hello everyone, welcome to this DevSecOps tutorial. In this video, I will guide you through setting up a secure CI/CD pipeline using Jenkins. By the end of this tutorial, you will have fully automated pipeline that integrates security at every stage of development. So let's get started. In this tutorial, we will cover the following topic. What is DevSecOps and why it is important? How to secure CI/CD pipeline using Jenkins. The tool we will use including SonarQube, Trivy and Dependency-Check and also a Docker. And at last we will see a live demonstration of setting up complete DevSecOps pipeline. Let's begin with understanding what DevSecOps is. DevSecOps stands for Development, Security and Operations. It is a practice that integrates security into DevOps process from the very beginning instead of adding it later as a separate step. The key benefit of DevSecOps are security vulnerabilities are detected early in development, reduces the risk of security breach in production environment, automates the security check without slowing down software release. In simple terms, we can say DevSecOps makes security part of software development process to ensure fast and secure application delivery. DevSecOps pipeline consists of several security stages. These include source code analysis to detect security flaw in source code, dependency scanning to check for vulnerabilities in third-party libraries, container security scanning to identify security issues, and deployment using Docker and Jenkins to securely release the application. Now let's look at the tool that help us to implement these security measures. In this tutorial we will use following tool: SonarQube for static code analysis, Sonar Scanner which sends scan result to SonarQube, Dependency Check to identify security risk in dependencies, Truvy to scan Docker images for vulnerabilities, Docker to build and deploy the application. Let's discuss each tool in detail. What is SonarQube? SonarQube is a static code analysis tool that helps developers to identify security vulnerabilities, bugs, and code quality issues in their projects. It provides detailed report on the quality of code and allows team to improve their software security. Now, what is Sonar Scanner? Sonar Scanner is a command line tool used to analyze the source code and send the result to SonarQube for further review. It helps to identify code quality and security issues. Now let's move to the dependency scanning. What is OWASP Dependency Check? Most applications rely on third-party library, but some of these libraries may have known security vulnerabilities. OWASP Dependency Check scan the project dependency and identifies the potential security risk. And what is Truvy? Truvy is a security scanning for Docker images. It detects vulnerabilities and misconfiguration inside the containerized application. It helps to ensure that Docker images used in production are free from known security risks. Now let's move to live demonstration and setting up a secure DevOps pipeline using Jenkins. Before proceeding to live environment practice, make sure you should have installed Jenkins, Git and Docker on your system. Hello, let's dive into practical. So in this practical, I'll be using Python Flask application and we will securely deploy it using Docker Compose and other security tools. We will go through building, scanning, securing the app to follow best DevOps practices. As already mentioned, there are few prerequisites. Jenkins, Git and Docker should be installed on your system. Step 1, to set up the environment, we will download and install SonarQube and Sonar Scanner. Go to your browser and type SonarQube installation and your operating system for which you want to install. Go to the SonarQube official document link and go to installation roadmap, click from zip file and click on distribution. Then you will see a page. As we will using a community build, this is the free, we can use it. Press download and give your email ID. Okay, this is not mandatory to provide. You can just download it and save it in one folder. I have already downloaded it, so I will press cancel. Now the next step, we will download and install Sonar Scanner. Go to your again browser and type Sonar Scanner download. Go to official document and click on Windows. My operating system is Windows and I have downloaded it. The next step, we will extract SonarQube services. Go to the folder where you have downloaded your SonarQube and now we will extract SonarQube first. Okay. After extracting, we will run SonarQube services. Go to the extracted folder, go to pane, select your operating system, open command prompt and run start Sonar. Now it is starting. We'll wait for some time to get it up. Go to your browser and hit localhost 9000. So SonarQube services is running on port 1000. Okay, services are up, you can see. Now we will log in with the user ID, default credential of user admin and password admin. It will ask us to update the password. We will update here. Make sure it satisfies all the conditions. Update. Now we have successfully logged into SonarQube. After SonarQube installation, we will generate token in SonarQube so that token can be used in Jenkins. Go to SonarQube, click on your username, my account, click on security. You will see generate token option, name token anything you like, Jenkins token I will say, and generate token type as a user token and click generate. Now token is generated. Make sure to copy this important token so that it can be used further. Now next step we will create an environment variable of Sonar token. This environment variable I will create one. I have already created with old name. I will update here. You can create a fresh SonarQube token. I have updated the token. Okay. Now the next, we have configured SonarQube. Now we will proceed for Sonar Scanner. Extract the downloaded zip file of Sonar Scanner. Copy the path till bin Sonar Scanner and add it in environment variable. Go inside user variable in path, click new and paste the path. Means do the same in system variable also. Click OK. Now we will verify if this command is working or not. Before that, we have to mention the newly created token in Sonar Scanner configuration file. For this, go to the Sonar Scanner file in conf. Open, there is one property file, Sonar Scanner.property. Open this and mention one property, Sonar Scanner. Make sure to update token which we have created. Now click on save and close this file. Now we will verify this command if SonarQube and Sonar Scanner have authenticated or not. Copy the command and use updated token. Now we will use this command to verify. Copy and check. Now it is working, means we have authenticated SonarQube and Sonar Scanner. Now we will proceed with OWASP dependency checklist. Go to provided GitHub URL and download the updated release. Once you have downloaded your updated release of dependency checklist, extract this and go to the bin folder and copy the path and mention in system environment variable in path. Yes, we have added the path of dependency checklist in environment variable. Now we will verify if dependency check is working. Yes, it is configured properly. Now we will install Truvy for container scanner. Go to the GitHub URL provided in the video description. Download the latest patch based on your operating system you are working on. I am using Windows, so I will download Windows 64-bit zip file. Once you have downloaded Truvy and extract it and copy the path and mention in environment variable. Go to environment variable in path I have provided the path of Truvy environment variable. Now we will verify if Truvy have configured. Okay, as you can see, we are getting output. So we have installed and configured SonarQube, Sonar Scanner, OWASP Dependency Checklist and Trivy. Now we will proceed with our simple web app creation. I have created one simple web application in Python using Flask. In this I have simply mentioned hello devsec words and running the application on port 5000. I have already pushed this code in GitHub. You can refer this link mentioned in video description. I have also created Docker file to create a Docker container, and I have also mentioned a Docker compose file which will help us to deploy the container. I have mentioned this GitHub repository in video description, where I have pushed app.py where the sample hello world web application is written, and Docker compose YML and Docker file. You can clone it and you can use it. Now we will configure Jenkins pipeline. Go to your Jenkins and before creating pipeline we will install few plugins. Go to manage Jenkins and click on plugins. Select pipeline. As I have already installed pipeline, you can see you have to install from available plugin option and install SonarQube scanner. As you can see, I have already installed it. And next, dependency check. Install dependency check plugin. After installation of plugins, go to manage Jenkins, go to configuration global setting, and you can see the SonarQube server and enable this checkbox environment variable. This means that the environment variable which we have set for SonarQube and Sonar Scanner Trivy, all those variable can be used by Jenkins if we tick this checkbox. Click apply and save, and at last take the Jenkins restart. Now we will create a pipeline in Jenkins. Go to your Jenkins dashboard, click on new item and name anything. Select item time as a pipeline and click on OK. Go to pipeline section and in the pipeline script copy the pipeline script which I have provided in document. So as you can see here, there are several steps. The first steps, check out of code. You have to mention your GitHub repository where you have pushed your code. Now static code analysis, we will use Sonar Scanner for that. For this you have, you have to mention project key here, the token, newly created token. Okay, and now dependency scanning, we are doing dependency scanning and we are building and scanning the image, and after, at last we are doing the deployment of our Docker file. Copy this script and paste in Jenkins pipeline, click apply and save. Before running Jenkins pipeline, I will show you if any Docker container is running on my system or not. As you can see, there is no container running currently on my system. Now we will build our pipeline. Click on build now. As you can see, pipeline has started and checkout code has successfully performed. Static code analysis has been done, and you can refer the log also. Static code analysis, it is done. Now dependency scanning is in progress. It will take some time. I will skip this step and I will so it is in progress. So it is completed. Now we are proceeding with next step. It is a building and scaling. Now the Docker container have been created and it is downloading the Python libraries Flask. Now the report has also been generated for dependency check. Now we are deploying Docker container, and you can see the job has run successfully. In previous, you can see it's job number 6. In previous, there was some network issue due to which all the vulnerability was not downloading from dependency check packages. So now we will, so if you face any error while doing the practical, so first check SonarQube is running or not. So here my SonarQube is running fine, and check Truvy and everything is installed properly, and also check Docker services are running. Now we will verify the details. So we will check SonarQube if reports have been published on our SonarQube portal. Yes, you can see we have our license key was and here all the results are passed. And dependency scanning report can be shown in our pipeline logs. If I open the pipeline here, as you can see here, the full log. This is the report summary. Everything is scanned as expected. Now we will verify our application is running on 5000 port. Yes, application is running currently, and we will check. Yes, Docker container is also created. Let's quickly recap what we covered. We started by understanding DevSecOps and why security is essential in CI/CD. We set up Jenkins and integrated security tools like SonarQube, Sonar Scanner, Truvy, OWASP Dependency-Check in our pipeline. We performed static code analysis using SonarQube to detect code vulnerabilities. We scanned for vulnerable dependency with OWASP Dependency-Check. We built and scanned Docker image for security issues using Trivy. And finally, we ran an application security test and deploy our application. By implementing this DevSecOps pipeline, we have successfully automated security checks and ensuring that vulnerabilities are detected early in the development cycle. Now, it's your turn. Try setting up this pipeline with your own project and experiment with additional security tool. If you found this tutorial helpful, don't forget to like, share and subscribe for more DevOps and DevSecOps content. Thank you for watching. See you in the next video. Bye.